Okay, so this is mine, and you know the names are gonna be the letters are gonna be slightly different. So just bye bye. So the names are gonna be slightly different, but it's still the same concept. They want minor arcs. Remember, like I said in the video on YouTube, minor arcs have 2 letters. So automatically, any of these that have 3 letters, you know are already wrong. And you can just get rid of those automatically without even having to think. Next thing you have to look at is if there are any semicircles named in there, because if there's a semicircle in here, then it's named incorrectly as well as not being what we want. So like let's look at all the diameters that we have in our circle here. Here we got the diameter here. So anytime we see a CB or a BC, we know we can cross that one out too. Let's see if we find one. CB, BC, hey, get rid of that guy too. And now let's see if there are any other diameters. Here's one from G to D, right? And all these do go up on YouTube, so make sure to look because I put all of these up there. So if we see a GD, an arc GD here, then we know that that's wrong, or DG. Hey, look, there it is, right? So all the rest of these, we've eliminated all the 3-letter ones. We've eliminated all the misnamed semicircles. So all the rest of these had better be minor. And so the rest of those should be the ones that are right. Okay, so with this one, what we need to be very cognizant of is the fact yes, but you gotta email me and let me know, okay? We gotta be very cognizant about the fact that basically what we have here is 2 straightaways and then a semicircle, right? Half of a circle. So for all of these answers, you need to go through and you need to say, all right, well, how big's the straightaway here? Funny. No, I'm talking about length. Like along the side. The width of the track is 20, but I'm talking about the straightaway. No, that's the width of the green part. I want the straightaway. The thing that I'm this thing. I want the straightaway. 84. There we go. So what we're going to do with that information, well, there's the straightaway. And then we need the semicircle. Right? For the inside track, lane 1, we just want the semicircle. What's the length around the semicircle? No, again, you're telling me the width of the track. I want what is the length around the semicircle, this part right here. I need to know how big that is. What shape is that? What shape is that? Right there. Yeah. If it was a whole circle, would you be able to find the length around the circle? Yeah, because it's just pi d, right? But we want a semicircle, which is half of that, right? So pi d, well, what's d? It's 42, right? But we only want half of that, ain't it? So now you got the length of a straightaway, the length of the semicircle part, and there's two of each, right? Straightaway, semicircle, straightaway, semicircle. So you can calculate the length around the inner piece of the track. Now here's the key to doing the rest of this. On either side of this semicircle, the straightaway doesn't change, right? The straightaway is always going to be 84. This part doesn't change. So the only part we actually care about that changes is the width, is the length that you run along the curved part. And here, look what it says. There are 8 lanes, and the width is 20. So for every one lane you go up, it's 2.5, isn't it? 2.5 on either side. So the diameter, so this is how much gets increased as you go along, which means that the diameter gets increased by twice as much. So this part doesn't, the 84 yards, as you go through 84 semicircle, 84 semicircle, that part's not, the 84 is not going to change. The only thing that's going to change each time is the length of this semicircle. And it's just going to be, you're going to do pi d, but now instead of it being 42 pi, it's going to be 5 bigger. And then you're going to go through and you're going to calculate by 2, because 2.5 times 2 is 5. The diameter increases by plus 5 each time. So 42 is the inner diameter, then 47, right? And then 52, right? These are the diameters. And then you're going to go through and you're going to figure out what the length of the semicircle is each time, and then just 84 plus blah plus 84 plus blah each time. And then you're going to do that and you're going to get your answer for each of them. Okay, so I had a question about this problem. This is asking about the surface area of the pyramid, and we talked a lot about in the video the formula here, and let me, it's unnecessary. See this, we'll show why that is in a second. But as you're going through, remember what the formula for surface area is. It's the area of the base plus the area of all these lateral faces. So each of them is a triangle, and the slant height is the height of the triangle. The perimeter is when you add up all the bases. So it should look like that. So what we need to do is we need to know, well, what's B?
what's P, and what's L? What's the area of the base, what's the perimeter of the base, and what's the slant height? Well, we go through and we know that the area of that hexagon is 1/2 times the apothem times the perimeter. Let me make this easier to deal with. I'm gonna move this over here so it's easier to deal with. And so the whole thing of it is, well, we need to know what the apothem is, and we need to know what the perimeter is. Well, one side of this hexagon here is 24, so all the sides, all 6 of them, 24 times 6, should be 144. So I'll put that right here because we need that anyway, right? And then the apothem, well, that's this arrow right here, the 12 radical 3. So you've got in the process of doing all of this, I'm still going to leave this radical 3 alone. Like even if I have to use a calculator, I'm not gonna crunch radical 3 because that's going to turn this into a really ugly decimal, and I don't want to have to do that yet. So I'm just going to leave it. I'm just going to do 1/2 times 12 times 144 in the calculator anyway. 864, and then I'm just going to put the radical 3 on top of that. 864 radical 3. And then the perimeter is 144, and then the slant height they give us is 24, right? So now look, I've got everything I need. Area of the base plus 1/2 times the perimeter times the slant height. So let's do that. I'm going to use a different color now. So area of the base plus 1/2 times the perimeter times the slant height. And then now I can, because it does say round to the nearest whole number is needed, so now I can just crank this out. 864 times square root of 3 plus 0.5 times 1. Ooh. 44 times 24. Or is that matches what I've got, right? 864 radical 3 plus 1/2 times 144 times 24. And so you should get, let me move this over here. You should get your surface area is equal to 3224.491898, 3,224, and 491,898 millionths. And we need to round to the nearest whole number. So since I want to round to the nearest whole number, I'm looking at that decimal spot. That first one, is this 5 or above? No. Truncate 3,224 meters squared should be approximately my final answer. And when I move that out the way, hey, look, that's what we should get, right? This is the correct answer. And that's all there is to it. Okay, so this is what we have. And what we want to do is we want to find the area of the blue part. Yeah? So let's find the area of the blue part. first thing we need to do is find the area of the big hexagon, and then we need to find the area of the little hexagon, and then we can solve. I'm gonna do the trig version just because it's less, but it's still the same idea. We're finding the radius so that we can find the area of one of these triangles and then multiply by 6 to get all 6 of them. So with the big hexagon, the small piece in here is 3, and then the piece out here is 3. So the entire radius, the entire radius is 6, right? That doesn't show up very well. Let's try a better color. The entire radius here is 6. So since we have the radius, this is actually a really easy thing to do because it's a hexagon, so there are 6 triangles, and each one is 1/2 AB sine of the angle, and this is a hexagon, so 360 cut into 6 pieces is 60. So x is 60, and A and B are 6. So we're just going to do 1/2 A B sine of, let me make more room, x, and then I'm just going to put that in the calculator. The small the small hexagon is the exact same thing. The only difference is that instead of having a radius of 6, it's got a radius of 3. So now instead of having 6 on the inside here, I've got 6 triangles, and A is 3, B is 3, and X is still 60. And I'm just going to figure out what each of those are, and I'm going to subtract them. And that's all it is. So let's do that. Let's put this in the calculator. 6 times 1/2 times 6 times 6 times the sine of 60. Make sure you have all your parentheses. Minus, I'm going to do this one now. 6 times 1/2 times 3 times 3 times the sine of 60. And then the calculator is just going to do the rest for you. So my final answer here is 70.148057771, and I have to double check because I don't know what it tells me to do. It says round to the nearest tenth. It says round to the nearest tenth, so I'm going to look at the tenths place. I'm going to look at that first decimal place, the tenths place, and then I need to look at the one after that to see whether or not I'm going to round up or stay the same, right? So I do that. That's a 4. That's not big enough to round up, so that all goes away. And I'm left with 70.1 feet squared as my final answer. So there are 2 parts to this problem. And so we should make sure to do both parts separately. Well, it is hard, but you don't learn by things being easy, right? if things were always easy, there would never be any growth. Success and growth come from having things be difficult and then working to overcome them. So anyway, nah. You just got to keep going. Keep trying. Anyway, look at what we have here. We have this is the other problem that you still have, number 6, I think. So, first thing they want is the perimeter. That's the hard part. My recommendation outside. Yes, the perimeter is the outside. So what we need to do is we need to find one of the sides so that we can add them all up, because they're all the same, right? Okay, good. So how are we going to do that? The easiest way to do that is first find this half right here. So what we need to do is we need to figure out what this angle, what this central angle is in here, and it's 360 divided by 8 is 45, and then we're going to cut it in half again, and we're going to get 22.5. That's our angle here. Let's not call that x. We use x for stuff. Let's call that y. So what we're going to do is we need to find this over here. We'll call that z. So we know y is already 22.5. We're going to have to go through and figure out what z is, and we're going to use trigonometry for that. We've got the opposite side and we've got the hypotenuse side, so we're going to be using sine. Opposite over hypotenuse. So what we need to do is we need to solve for this thing right here so that we can get the whole side, right? So we're going to cross multiply and we're going to get z equals 13 times the sine of 22.5. So that's half of a side, right? So what we need to do is we need to multiply that to get a whole side. So that's this right here, yeah? So what we have, this is half of the side. 4.974884621. That's half a side. So it's a whole side. Just times 2, right? So the whole side, when we multiply by 2, we're going to get 9.949769241. That's one side. But how many sides are there? Tell me how many sides there are. Yeah, because it's an octagon. 1, 2, 3, 4, 5, 6, 7, 8 sides, right? So now what we have to do is we have to say, all right, well, this is one side. Well, what's 8 of them? So I'm going to times by 8. So I can get the perimeter. Oops. This right here, that is the perimeter. And then we need to ask ourselves, how do they want it written out? And they say to the nearest tenth, right? Round to the nearest tenth. So let's draw the line on the nearest tenth, is right here. And then we look at the number after the nearest tenth. That's going to tell us what we have to use. And, well, this 9, that rounds up or down. Does 9 make it round up or down? Yes, 79.6. That's exactly right. And that's meters.
Okay, so the second part then with the area, right? So now they gave us the easy job here now, because remember, just like when we were doing this one right here, we want to find the area of the shape. So it's going to kind of be like that. But now instead of having 6 sides, we have 8 sides, right? So we need to know what A is, what B is, and what X is, so we can type it all into the calculator. So look, what's A and B? They give it to us right here, yeah? Exactly. So that's what we're going to put here, right, for A and B? 13 goes here, 13 goes here, and now we need to find X. Well, the whole circle is 360, and there are 8 sides, so we're going to divide that by 8, right, to get that central angle. And what's 360 divided by 8? Yes, 45. So that's our X. So let's put that in where it goes here. And that's all there is to it. Now we just put it into the calculator. So let's calculate this out. 8 times 1/2 times 13 times 13 times the sine of 45. And that's what we get. Now the question is, how do they want it rounded? Do they want it rounded to the nearest tenth, to the nearest hundredth, to the nearest thousandth? What do they want? Tenth. Okay, so then we gotta look, right? If it's the nearest tenth, tenth means we look at the first decimal place, put a line after it, and then we say, all right, what's the next one? Well, that's a 0. So is that big enough to round up, or do I have to just get rid of it? Yes, exactly. And that's meters squared for your units, right? And that should be already there, I think. So you don't have to put meters squared in the box. You just have to put the 478.0.